with our Unit 8 on exponentials. We're going to continue talking about exponential graphs today. We're going to focus on the transformation rules. We touched on them yesterday. I reiterated that transformation rules are the same for every function we've worked with. We've done absolute value, quadratic, square root, cubic, cube root functions. So we've done 5 functions before exponentials and talked about the transformation rules within all of those. So the transformation rules are not changing. Where those values a, h, and k appear in the function, that's really all that changes. It's what is the original parent function, and so what does that a, h, and k look like in this new parent function, or in this new function. So our h is our horizontal shift, and that is always subtracted from x. So since x is in the exponent for exponential functions, that minus h is up here in the exponent with the x. So if there is a value added or subtracted up in the exponent, that means there's an h value. Okay, so if you need to make side notes, we've talked about this a bunch, but if you need to write it down again, make yourself a little note that h is your horizontal shift. Okay, that means left or right. And remember that the minus is in the equation. So x minus h, that means that it's shifting to the right because h is actually positive. If it's x plus h, that means it's minus a negative h is negative, and that's a shift left. Okay, so it's the opposite direction than you would think based on the sign that you see in the equation. Okay, the plus k, we actually talked about this one yesterday the most, I think, because we talked about how this shifts our graph up or down. Because remember, k is your vertical shift. Okay, so that shifts your graph up or down. Now, the graph of exponentials has a horizontal asymptote. And when we shift our graph up or down, that asymptote shifts with it. So when we were practicing yesterday, graphing these exponentials, that's always what we started with, was if there was a k value here, if there's something added or subtracted on the outside, that is telling us where that asymptote will be. Okay, so don't forget that there is a horizontal asymptote. In the parent function, it's y equals 0 because there's nothing added outside here. There's no plus k, so that's like plus 0. So y equals 0 is the asymptote. But once you have something plus k, that is the location of your horizontal asymptote. It's going to be at y equals whatever k is. So k tells us our vertical shift, and it tells us the location of that horizontal asymptote. Now, it's not listed here. I'm not sure why it didn't get printed to be on here, but your a value is in front of the base. Okay, 2 is what's being raised to the power. Okay, but sometimes there's a number in front being multiplied. Okay, and that would put your base in parentheses, or they might just put a dot to show multiplication of those two. Okay, it just depends on how it's written. Okay, but that a value, okay, if there is one, if there's no number written in front of the base value, a is an understood 1. Okay, but if there is something written in front, that is your vertical, and it could be a stretch if it's greater than 1, or a compression if it's less, it's between 0 and 1. okay? And it could reflect the graph, okay? Because if it's negative, it's going to reflect. So, and or reflection over the x-axis, okay? A vertical reflection. So let's jump into these where they are giving us a parent function with whatever the given base is. In this first one, it's a base 2. Okay, and then they're asking us to translate it. They want us to graph it and describe the transformation. And then under the graph, there's a whole bunch of information we want to identify. Okay, so I'm going to start with the description. Okay, so we said here that the A value stretches or compresses the graph. Is there an A value in this example? Okay, is there something in front of the B being multiplied? Yeah, yes or no question. So the 2 is the base value. Okay, it's 2 to the power of x is what we started with. So the 2 has not changed. That is my base, my B. A shows up in front of that being multiplied. Is there anything in front of that 2 being multiplied? No. So our A value is just an understood 1. So there is no effect by that on our graph. So it's not going to be reflected. It's not going to be stretched or compressed vertically. Okay. Now, what's different from this parent function they gave us to this one? The first difference is this +1 in the exponent. So that is my h value. Now, because it's a +1, that means the h is actually negative, and that does affect the graph. That shifts the graph left 1. And then there is a k value, something added or subtracted on the outside there. It's a -4. So k is -4, which shifts our graph down 4. And that right there tells me where my asymptote is. So my asymptote is going to be at -4. So that's what I'm going to start with on my graph. I'm going to go to -4. I'm going to draw a horizontal asymptote, a dashed line. Okay. Now I need to plot, when we were graphing yesterday, we were plotting at least 2 points. If you can fit more than 2 points, plot more than 2 points. Okay. Now, this is a basic transformation. So since they gave us the original function, I'm just going to take points from it and I'm going to move them based on these transformations I just described. So I'm just going to take that point and I'm going to move it left 1, down 4. So I'm going to go left 1, 1, 2, 3, 4, down 4. Okay, so that point would have just moved to here. Okay, now I need at least 2, so I'm going to pick a second point. I'll take this one, I guess. And I'm going to go left 1, down 4. Now, technically 2 is enough, but I think I can fit a third. So the more points I have, the more accurate the curve. So I'm going to take, here's another one that's at the intersection of the grid line. So I'm going to go left 1, down 4. Now that one puts it right on top of this old purple one. That's okay though. It can overlap. So now I've got 3 points and my asymptote. I can sketch the curve of this exponential pretty accurately with that. So I'm going to do that. So it's going to come up from here through these points, arrows on both ends. They have the original function there, and I took those points, I took that curve, and I shifted it left and down. And the asymptote, when you shift left or right, that does not affect the horizontal asymptote. Okay, but shifting up or down does. The asymptote shifted down with the graph. Okay, now we talked about yesterday, you can use Desmos to help you get points. So if you are not confident in that you did the transformation description accurately, or transforming the points or picking the points and where they should go, just go to Desmos and type in your equation. Okay, this one was 2 to the power. Now, when there's something in the exponent with x, you do need to use parentheses so that that plus 1 will be in the exponent. If you don't use the parentheses, when you start to type something after that x, it moves it down. And then you had minus 4. So there's my equation, and I can check the graph here. This looks like there's the horizontal asymptote here at -4. That's where we drew ours. Okay, that's good. This y-intercept's at 0, -2. That looks like where mine crossed. I didn't plot a point there on mine, but that's where I crossed over here. If you look at it closely, crossed at -2. Okay, but I picked other points, so let's check those. Here's a point at -1, -3. I did plot that one. Okay, here's a point at 1, 0. I plotted that one. And then there was a point at 2, 4. That's the other one I plotted. So the 3 points that I plotted are accurate. Okay, I could have plotted more if I wanted. Now, if you don't want to just click on your graph and drag and see what the coordinates are, because sometimes it's hard to get exact values, okay, just come hit the gear button. Remember, this will pop up next to your functions, that whatever you have typed out, and you can click to create a table, and it will give you a table of values. So you can see those points that we plotted. There's the -1, -3, the 1, 0, and the 2, 4. There's more points. I didn't plot all of these. And if you need additional values, you just type them in, and it will automatically fill in what the y value should be when you type in the x value. So if you need help getting points to plot, you can get a table from your function in Desmos. You'll feel okay about that? All right, so now let's answer these questions beneath the graph, okay, that are asking us for lots of information about this function. Okay, so first of all, what type of function is this? What is this whole unit going to be about? Exponential. Okay, so this is an exponential function. Now it says with a blank asymptote, because asymptotes can be vertical, they can be horizontal. Okay, we are not going to have vertical asymptotes in exponentials. Okay, we'll talk about vertical asymptotes later with other functions, but not exponentials. Exponentials, that asymptote that we drew is horizontal. Excuse me. Now, where is that asymptote? Where did we draw it? Okay, and make sure you put y equals -4. Because a horizontal line's equation is y equals the number where it crosses the y-axis. So it's at y equals -4. Now, that is going to help us determine our range. What is the range of this function? If that asymptote is at -4 and the exponential is above the asymptote, what's my range? What's the lowest y value this graph is ever going to approach? Good. Yeah, the lowest it's going to get is -4. Now, it's not going to ever reach -4 because this is an asymptote. So that's why they've already got the parenthesis drawn. It's -4. And then somebody said it's going to go up to infinity because it goes up forever. That's correct. Okay, now they want to ask in the next blank, it is blank on its domain of blank. So they're asking the behavior of the graph. So is this graph increasing or decreasing? Good, because we read a graph from left to right. So this graph is increasing on its domain. And what is the domain of all exponentials? All real numbers, but they have it set up for interval notation. So it's negative infinity to positive infinity is how we would fill in those blanks. Now, this last part is new. I have talked about, I've said the words end behavior. Okay, it's what the ends of the graph are doing. Okay, but the way that we write end behavior, okay, that's going to be new. We haven't done that with other functions before. So the end behavior, the ends of the graph are on, there's the left end and the right end. Okay, because end behavior, we're talking about the left and the right. So the left end of this graph, okay, is going to the left. Obviously going to the left. What x value are we approaching if we go left forever? What's to the left? Negative infinity. I'm going to mark that on my x-axis. This is going toward negative infinity this way. And to the right, it's going toward positive infinity. Do y'all agree with that? That's the domain we just gave. So the way that we write in behavior always starts with x approaches. And the symbol for that is x and then an arrow. So left means that x is approaching negative infinity. Zoom in on this. Make this a little bit bigger. Okay, so x is approaching negative infinity. So that is the left side of the graph is written as that. Left means x is approaching negative infinity. And we can see it up here. The left side goes to negative infinity. It won't let me highlight that, but I wrote negative infinity up there on the x-axis on the left side. Now the right, what is your x approaching if you move to the right? Positive infinity. So for the right side, I'm going to start my end behavior with x approaches infinity. You don't have to put a positive. Positive is understood. Okay. So the right side is written as this. So x approaches negative infinity means left. X approaches infinity means right. Because that's how the x-axis goes. Left is negative infinity, right's infinity. Now, the second blank is what the function is doing. Now, x, what's our other variable besides x? Y. And when we talk about y, there's another way that we've written it all year. We say, what's the same thing as y? F of x. That's the name of the function up here. F of x. Okay, so we're saying as x approaches negative infinity, we want to state what f of x is doing. Now we write f of x with an equal sign. So as x goes toward negative infinity, so this means as my graph goes to the left, what is the f of x means y? What is the y approaching? What y value is it getting closer and closer and closer to as this graph goes to the left? It's not going to go down to, the x is going to negative infinity, but what's the y value approaching? -4. Good. And what about on the right side? As this graph goes to the right, as x is going to the right toward infinity, what's our y value going toward? Positive infinity. Good. So we'll say f of x equals infinity. You'll notice that these terms came from the range. Okay. And in this case, it happened to be that the left side was approaching the bottom of the range and the right side was approaching the top side, the top part of the range. Okay, so this end behavior notation, that is new. So make sure that you've got that down. If you have questions about it, ask. Okay, we're going to do it with a couple more examples, so I'll go a little bit quicker. But this is the format that you're going to be writing. And the way that you read this, it's as x approaches negative infinity, f of x is -4.
Useful.
Up, yeah. You see the graph? Okay. So that's what we're going to do. We're going to do 2 more examples together, and then y'all are going to have a chance to practice this yourselves in Delta Math. Okay, so we are describing the transformation based on the equation given. We are graphing it, and then we're giving all these details about the graph underneath. Okay. Good, Preston? All right. So let's flip to the back of that page. Now this one's starting with a different parent. It's still a parent function. It's just a different b value. Remember, the parent function is b to the x, but we have to have a number for b. Okay, so our base this time is 1/2, which we discussed yesterday meant that our graph is a decreasing. It's exponential decay. It's going down left to right. Okay, so the b value being between 0 and 1. Okay, and they've graphed that 1/2 to the power of x for us. Now they want it to translate to become this function. Okay, -4 times 1/2 to the power of x plus 3. So let's describe what's going to happen to this graph with this -4 in front and this plus 3 at the end. Those are the changes. That's what's different from the original. So if that -4, is that A, H, or K? A, good. Okay, so the A is -4. Now, what does that do to my graph? How would you describe the transformation? The negative means that it's going to flip, good, flip or reflect over the x-axis. It's a vertical reflection. Okay, what about the 4? What does it do? It's going to be a vertical either stretch or compression. Good, because it's greater, 4 is greater than 1, so it's a vertical stretch by 4. Okay, so it's going to look taller, more narrow than the original. Okay, when we do that stretch. Okay, the distance between each point, the distance between each point isn't going to change, but vertically it's going to be stretched by 4. Okay, now there is no H value here. I'm still going to go ahead and just label it for the sake of y'all seeing. H is 0. There's nothing added or subtracted to that X. Okay, but what is K? K is a +3, which means this graph is shifted up 3. So we are going to reflect it. We're going to flip it, stretch it, and shift it up. Okay, that's our process. Now, can anybody tell me where the asymptote will be here before we start trying to move point? At 3. Remember, it's always going to be at y equals k, and k is 3. So we're going to draw a line at y equals 3. That is my horizontal asymptote. We can go ahead and label that down here. It says a horizontal again. These are all going to be horizontal for exponential. Asymptote of y equals 3. Okay, so I've got that part. I've got it sketched and I've got it written down here as my horizontal asymptote. Now, the point, you can do what we did on the last one and just take individual points and make these transformations, or you can use Desmos. Okay, you use the method that you prefer. Okay, but let me show you with this a couple points. So here's this point. It's starting at the y value is at +1. If I reflect this over the x-axis, it'll be at -1. Yes? So if I were to flip this graph over, that point would be here at -1. Now, I need to stretch it. I need to multiply it by 4. So what's -1 times 4? -4. So it's going to come down to -4. Now I need to shift it up 3. So I just go up 3 from there. Now that actually puts me back at that -1. So that's where that point is going to end up. Okay, let's try it with another point. This point here. If I reflect it over the x-axis, it's going to be down here at -2. What's -2 times 4? -8, right? So I multiplied by 4. It'd be down here at -8. But then I need to shift it up 3. It's going to put it here. Okay, there's no other integer like intersections of points that if I shift, they're going to fit on this graph. Like this one up here is at 4. So if I reflect it to -4, when I multiply by 4, it's going to go to -16, which is off my graph. And then up 3 would be at -13, but that's off my graph. So I can't plot that one. Okay, and then if I go to the right to move points, these are all fractional values. So I'm just going to plot these two for now. If you prefer to use Desmos, again, this is what it would look like in Desmos. I would type my equation. Okay, this time I've got a -4 in front being multiplied by that 2, which is raised to the x. There's no +1 this time, no h. And then my k is, you can come grab the notes over here, Henry. It's right here on the end of my desk. +3. Okay, so let's check out. Here's what the graph is going to end up. Oops, did I type that in right? Oh, nope, I need to change my base. I was like, that does not look like what I'm graphing. There we go. Base is 1/2. Okay, so now this looks like what I'm graphing over here. Let's check some of those points. I plotted a point at 0, -1. Hey, there's a point at 0, -1. I plotted a point at -1, -5. Hey, there's a point at -1, -5. Okay, so it looks like the asymptote is at 3. That's where I sketched my asymptote. Okay, so I could go ahead and sketch my curve and I can see in Desmos that that's accurate. Okay, if I wanted to make a table, I could make a table and check. Here's that point I talked about would be off the graph at -13. It wouldn't fit. Here's the 2 that I did plot. Now, if you want to plot additional points, here's more points that would fit that you can plot. So I've got -1, -5, and 0, -1 plotted. I can also plot 1, 1, and 2, 2. Those would fit on my graph. So if you want to plot more points to help your graph be more accurate, 1, 1, and 2, 2. Go ahead and plot those. Okay, now I'm going to sketch that curve. Come through these points and approach that asymptote to the left, or excuse me, to the right. And that matches what Desmos showed as well. So we've done that accurately. Y'all feeling okay about graphing? You can use Desmos and make yourself a table if you need to. If you don't like doing it by hand and actually shifting the points, that's okay. So what type of function is this? These are all exponential. Okay, so this is an exponential function. We said it's a horizontal asymptote at y equals 3, which now I can give my range. On the last one, my range was k to infinity. This one, because it's reflected under the asymptote, it's not from k to infinity, it's from -infinity up to k, which is 3. So it's -infinity to 3. Okay, it is increasing or decreasing when I trace it left to right. Am I going up or down? Up. So this is increasing on its domain. The domain never changes for exponentials, always negative infinity to positive infinity. So now let's talk about that end behavior. This was the new piece. We said the left, that is always going to be x approaches negative infinity. The right is always going to be x approaches infinity. That's how we write left and right end behavior. Okay, now what are we doing on the left and right? Okay, what is this function approaching? So you're going to have f of x equals. So the left side is going where? What y value are we going to on the left? What does this arrow tell us? Where are we going? Negative infinity on the left. Okay, what about on the right? What y value is this getting closer and closer and closer to? As my graph goes to the right, what's the y value it's approaching? 3. So again, those values come from the range. Questions so far? Right. Last one. Okay, this one starts as 1/3 as my base. So 1/3 to the power of x is drawn here for us. They want us to translate it with these, describe the transformations, and answer all those questions again. Okay, so my a value is -1. There is no number written, but there is a negative here. So it's a understood -1. So this graph is going to reflect over the x-axis, but it's not going to stretch or compress. So reflection, yes. Stretch or compression, no. Okay, the h value is 2. Remember, it's the opposite sign that you see there. So that says x minus 2, so h is a positive 2. This graph is shifted right 2. And then your k value is also minus 2, but that actually, you keep that sign. So k is -2, so this graph is shifted down 2. So now let's draw it. -2 is my k. That's where my asymptote will be. So I'm going to start with my asymptote at -2. Okay, we can go ahead and fill that in down here. Y equals -2 is my horizontal asymptote. Now, before I even sketch it, I know that this graph is reflected. So it started out looking like this. I got to flip it upside down under the asymptote. So what's the range going to be if it's under the asymptote? If my graph is going to be under the asymptote here, what's the range? It's going to come from -infinity up to k. So -infinity to -2. So if you want to go ahead and write that before you draw it, you can. A lot of this can be filled in before we draw the graph. Still an exponential function. The domain never changes. Now, when we flip this over, right now this is a decreasing graph, but when I flip it upside down, what's it going to be? Yeah, from left to right, it's going to be increasing. Now, if you've got a decent understanding of that end behavior, it doesn't matter exactly where the points are, as long as you know the general shape and where the asymptote is. I know that the left side is going down to -infinity, and the right side is coming up to -2. So I can go ahead and say, as x approaches -infinity, that means left, the function is going to -infinity. As x approaches positive infinity, that means right, the function is going to -2. So I've answered all of this without actually seeing the graph. If you have a good understanding of the general shape of the function and the what the transformations are, where that asymptote is, and if the function's above or below it, or increasing or decreasing, okay, you can answer all of this. Okay, but we do still have to graph it. So I'm going to get some points and make these transformations. So again, you can pick points. So I'm going to pick this point here. I'm going to reflect it. So it's going to be at -1. And then I'm going to go right 2, down 2. And here's where it'll end up. Okay, I could pick another point. And I could reflect it. So it would be at -3. And I'm going to go right 2, down 2. And 2 points is enough to graph your curve. And in this case, that's actually all the points that we're going to be able to fit on here that are integers. All of the others that would fit in here are going to be fractional or decimal values. So I'll just go with those 2 points and sketch my curve. And you can double check it in Desmos. You can verify with the way that we drew that. Does it match everything that we said about this? Okay, and it should. Okay, but we'll double check it. It was negative, and that was 1/3, and x -2 up there, and -2 down here. So that graph looks like what I did. I got a asymptote at -2. Okay, the points that I plotted were at 1, -5. Let's see if I can get on it exactly. This is what I'm talking about. There it is. 1, -5. That's right. And then I plotted at 2, -3. It's hard to get exactly on it when you're scrolling. Okay, but you can. Okay, or you could always just gear, table, and check the points that way. And the only ones that would fit on here are that 1, -5 and 2, -3. If I went past that, I start getting decimal values. Okay, and to the left of that, they're too low to fit on this grid that I was given. Okay. That's it for today. We're just practicing those transformations and being able to describe them and give the key features based on those transformations. So what it looks like in your Delta math, sample student page here. So you'll definitely see today's 220. If you still see yesterday's practice, I know we didn't have a lot of time in class to try it. It's short. It's only 6 questions. Maybe you finished it up in Cat Tracks or at home, but if you didn't and you want to knock that one out first, do that. Okay, that one is due first. Okay, that one is actually graphing. Okay, you have to state where what type of asymptote you have, and then you move the asymptote where it should be, and then you move your 2 points to plot where they should be, okay, and then you check your graph, okay? Then today's practice, okay, on exponential transformations, okay, you're given the graph. The graph is graphed, you're given the equation. It's just answering all that descriptive stuff we were talking about in the notes. So the end behavior, where is the asymptote? What is the domain? What is the range? Okay, is it increasing or decreasing? Okay, so you're just, and it's all drop down menus. Okay, so you're answering all of this based on the given graph, but you're not actually having to graph it. Yesterday, you graphed. Today, we're using the transformations to answer all of these questions. Okay, so you've got the rest of class to work on that. You can, of course, have your notes out. You can talk and work with each other. You can ask me questions. Okay, pay attention to those due dates. I would work on yesterday's first if you didn't finish it.